Now let's go back to the standard graphs of trigonometry graph. Okay, have a good look of them, and well, please copy it down in your notebook or print this page out because uh, you need to know them when you sketch more complex graph trigonometry equation. Now I do some more analyze on this kind of graph. Well, what's happening is in trigonometry graph they normally looks like that. Y equals to a cosine, sorry, normally they look like y equals to a cosine or sine bracket bx plus c bracket and plus d, okay, which is there. Okay. Okay. Um, in your the first coefficient a here, it means the amplitude. Okay. So also what is the amplitude is if we have if I have a standard graph, if I have a sine graph there, okay, if I have sine graph, something like this, or cosine graph, the amplitude basically is the height of the sine wave. Okay? Sorry. This is the sine. It's basically the height of the sine wave is called amplitude A. Okay? I labeled here from your maximum, the distance from your maximum number to your neutral line here. Okay, y equals to 0. We call it the amplitude, and well, similarly, the horizontal span in a period, we call it a period. Okay. A is the amplitude. If A is a minus number, means you will have a reflection on x-axis, so the graph looks something like this. Okay. Now, the letter B here indicates the period. Okay. And the period is always 2 pi divided by b, which is the coefficient of x inside the bracket there. Okay. And when we have something like plus c, okay, we make whatever in the bracket equals to 0, and we have x to find its horizontal translation. If x is positive, means it moves to the right. If x is minus, means it moves to the left. We call it a phase change. Okay. Basically, the plus c indicates there's a phase change in your graph, and means sometimes you have to the graph shift to the left or to the right, depend on the value. Okay. And the coefficient d here, okay, is your neutral line. In your standard graph, y equals to sine x, your neutral line is y equals to 0. And now what's happened is, if y equals to d, the straight line is your neutral line. Okay. I do an example here. So for instance, if I have a trigonometry equation, y equals to sine x plus 10, okay, the graph would translate 10 units up. Okay, the graph would translate 10 units up. So y equals to 10 is your neutral line there, and the graph would look like this. Okay, and here also your amplitude will be there, and in this case your amplitude is 1, so your maximum point, okay, 10 is here, is 11, and your minimum point there has the y value of 9, which is 10 minus the amplitude, or sorry, 10 plus the amplitude, and 10 minus the amplitude. Okay, so your maximum point of a trigonometric sine wave is going to be d minus a, d plus a is your maximum point. Your minimum point will be d minus a, okay, which is amplitude if the whole graph moved up, and the amplitude doesn't change, but the maximum point of the graph changes, which you can find it by just d plus a. Okay, now let me do an example. Okay, okay, say if I have a an equation called y equals to 2 cosine let's say maybe x, 2x plus 5. Say if I have this equation here, okay, and the graph should have a cosine bx plus c plus d. Okay, our standard graph is y equals to cosine x, which looks like this. This is your x, this is your y, this is 2 pi, here we have pi on 2 at this point, and 3 pi on 2, okay, for this intercept, and the maximum point is 1, the minimum point is minus 1. Okay, now let's say the amplitude of the graph. In here, the amplitude of the graph is 2, because a is 2, and okay, let me make it clear. So compare the graph given the question with the graph in ABCD format. A is 2, and B is also 2, C is 0, and D equals to 5. Okay. What's happened is so your amplitude is 2, okay, and the period, which is 2 pi is the period in the standard graph, divided by b, here, okay, which is 2, well,